Hi everyone. Hi everyone. And besides our speakers, we have an expert today, Vladimir Sitnikov. You might know him on Heisenbug conference. He is a performance engineer at Netcracker. Hi folks, how are you doing today?
Hi, doing fine. What about you?
Great. Nice to hear it. Well, I looked up something about SQLancer, and I see that logo of your system is a lens and a windmill, and this, of course, reminds us about Don Quixote. Why is it so? Is it because it's useless to find all the bugs? What do you think?
Yeah, so actually the story goes back. Actually, it was not my idea, but a colleague, Cheng Chang, he came up with this idea because basically the problem of finding logic bugs in database management systems is quite difficult. And this is basically represented by the logo.
I see. Yes, and but your technology focuses specifically on database systems testing. Why is it so? Can you tell why did you choose database testing?
Yeah, there is actually an interesting story behind this because I was using a database management system myself as part of some research. Basically, I was mining some software repositories and I was storing the results of the mining study in a database. And basically, after a while of running the experiments, the database got corrupted. And basically, I lost some progress of my work, which was very frustrating. And I didn't immediately pick up the topic, but basically, after I started as a postdoc, I thought back again about the experience and then thought about new ways of testing database management systems.
I see. Ilya, and you're the person who used SQLancer to test ClickHouse, right? Can you tell us how did you manage to come across the SQLancer and your experience with it?
Yeah, sure. Actually, I just got a message from our colleague in Telegram chat about, look, here is the code of SQLancer published on GitHub. You should look at it's a great good work. So I just read the papers about it and wanted to try it out with ClickHouse. And actually, when I looked at it, there was something like a draft of a ClickHouse integration. So it looked like we just need to get it and try to get it to work. But actually, it took a bit more job to start testing ClickHouse. And so I'll tell it in our talk.
Okay. I think we'll hear the rest of the story during the presentation. So let's move on to your presentation.
Sure.
Okay, sounds great.
And before we start, we can tell that there is a small gift for the best question that you will ask after the presentation, or in Q&A session, or in the Telegram chat. So find good questions and don't be shy to ask us. So I'll start. My name is Ilya, and currently I'm the part of ClickHouse team in Yandex as a technical project manager. Yes, sometimes managers have background that allows us not only to read code, but also make contribution to open source. So as you can see, I'm not alone today during this talk, and we are here together with Manuel. It is probably interesting how we met and why we're here together. So Manuel published a number of papers about correctness checks in database management systems, and moreover implemented testing tool called SQLancer. I heard about this research, and as soon as it was open sourced, I was one of the first external contributors to this project. And actually, when I saw his paper the first time, I was shocked that such natural and almost obvious testing approach has not yet been used like 20 or 40 years ago. So then Manuel called me to join him at this conference, as he thought it will be interesting to share both the theory and practice of database management system testing in this talk. So Manuel, can you tell me about yourself?
Yeah, sure. I guess it was now already mentioned a couple of times, but my main background is in academia. So I'm a researcher trying to find new techniques on how we can improve the reliability of software. And specifically, I'm researching automatic testing techniques. And for the last 1 or 2 years, I've been now working on testing database management systems in order to find logic bugs. So that's basically my background.
Thank you, Manuel. So we have quite a long talk today. So I'll make a forward declaration of what we are going to tell. So in the beginning, I'll briefly tell about ClickHouse and why we need thorough testing. Then I'll describe our paths in testing and that we already walked through what current problems we have and why we believe approach of SQLancer will dramatically help us. Manuel will then describe the theory of metamorphic testing and testing oracles. It is not difficult as it sounds, and he will show 3 families of testing oracles with examples and bugs found by them. And in the end, I'll show what it looks like to add yet another database management system to SQLancer to show the idea, and that's not the very difficult work to be done. So to start with, I want to make a point that actually we need more automated testing techniques to test different systems for correctness. And actually, we are just in the beginning of this way. So I'll start about ClickHouse. I work in Yandex, and it's a quite big company. You probably know it, but and we have separate department that builds infrastructure and is used by our colleagues. We encounter really big data and high load. Sometimes existing software can't handle our workloads, and we have to develop in-house solutions. Some products currently become available in Yandex Cloud. Some are become open source. For example, CutBoost and ClickHouse are available under Apache license, and you can use them wherever you want. So I think there are people who know what is ClickHouse, but let me introduce it once again. So ClickHouse is an analytical open source database management system for big data with SQL interface. So ClickHouse is a columnar database management system, which allows you to read only those columns that are used in query and allows to run complex analytical queries basically fast. So it is almost linearly scalable. We know installations with hundreds and even thousands of servers, and there is currently no obstacles to make them even larger. And ClickHouse is fault tolerant. We need to store data and not lose them during server faults, data rot, network bit plates, and which is more important, software upgrades. So why do we need good CI? We are currently on the conference about testing, and I will cover a bit this area a bit deeper. So we are trying to become the #1 analytical database management system. And we actually believe that anyone can contribute to ClickHouse. There are no privileged places that are changed only by core team. We try to nurture our community and make it easier to make available contributions. So there is numbers on the slide. And actually, we succeed in growing our community. And currently, we see exponential growth of external contributions. And here is an example of what a query to ClickHouse looks like. It's a screenshot from our web UI that is integrated in ClickHouse server, so you can see the query and result. Actually, we've downloaded all the public GitHub data and put it in ClickHouse and made it publicly available, so you can open. So we opened it for everyone, and you can just open this web page and make your queries that you want. This one that counted our contributions from the previous year was like 45 milliseconds to get result.
Yeah, so I actually also want to have a chance to win the book. So let me ask the first question. So since it's a conference about testing, can you tell us a bit about how ClickHouse is tested, Ilya?
Yes, sure. I believe that I could start a bit earlier because the amount of external contributors is really large, and we can't know personally all of them and know which quality of the code they usually write. So we still have to maintain the quality of the code base. At first, we practice code review on GitHub and run tests in CI. I believe that there can be a separate talk about our CI because actually there's a lot to talk about. But in a couple of words, we have all the tests and builds portable. It's based on containers in Docker, so you can just download the clone repository, so download the code, install Docker, and run or build any test from our CI. So actually, our CI just runs Docker containers in pull requests and in master and handles the result to show you. So what is about ClickHouse testing? We do love all types of test techniques to test ClickHouse. So here you see a small list, but I will not go through it because I believe you know lots about it. But actually, it's even bigger because I haven't retyped all these checks on the previous slide. So we store all the results of the tests in ClickHouse. So we love ClickHouse and put all the data to ClickHouse, and then we can analyze the data and visualize it, or even create monitorings. And for each commit, we have more than 100,000 tests. It's a large number, but we cannot just tell if it's enough or not just looking at this number. We should look at some proxies of quality itself. For example, how often we see issues that are reported from other users. We can collect code coverage and to see which functionality is not tested well, and try to improve coverage by adding tests for these parts of code. But this approach is very time-consuming, and it needs, comparing to the significant increase, we need to invest too much time, and we don't have such big team to increase code coverage for all the external contributions. So we have another way how we improve coverage. It's called fuzzing. This technique usually means that we try to give random inputs to a program and try to trigger crashes. So we used leap fuzzing as the most common fuzzing tool to test, for example, column definitions of our tables. This library collects information about branch coverage and uses it to mutate input in a way that improves coverage. We also use instrumentation like address and memory sanitizer. It also helps us a lot to check code sanity, especially when running with fuzzers. We wrote thread fuzzer that switches running threads randomly and allows to trigger bugs and data races. And there is one more advanced fuzzer that mutates queries and tests and mixes them just to get new queries for our ClickHouse. So this is called abstract syntax tree fuzzer, and it was very effective in our case. Now we can see that during the new pull request, we can trigger bugs that are just were introduced in this pull request. And there was one hilarious situation. We set memory and time limits for this queries that are returned from the fuzzer, and at some point, fuzzer learned how to disable the query timeout. So summing it up, we had some steps in our testing. First one was like using common practices. Unit functional integration testing, you know, I guess a lot about this. Then we added instrumentation where possible. So we run all tests with sanitizers. The next step was creating different fuzzers. But now we have one big problem that we cannot solve with these techniques. It is very difficult to test database management system for correctness. So we can, for example, take a qualified developer or QA specialist that will validate that the result is correct for given data and the query. But it's obvious that we cannot check all the data available, and we need another approach. So we can try to find a reference system and to check whether it has the same result like in the reference system. But it's also very difficult to use it, because if you have some SQL extension, you cannot check it in another database management system if it has not this extension. If you have different results in two databases management systems, you can have bug in either of them or just have implementation-defined behavior. So how can we check for correctness? We thought about correctness checks, and we believe that SQL has some invariants that should help us. And database management system probably should know SQL better than every single human. So we can use the database management system itself, and SQLancer can help us to check if it is correct or not. So Manuel, can you tell what is SQLancer?
Yeah, sure. So if I had to describe SQLancer in one sentence, I would say that SQLancer is an effective and widely used automatic testing tools to find logic bugs in database management systems. Let me first give you a couple of facts about SQLancer. SQLancer is written in Java and uses Maven as a build tool. It's actually quite straightforward to get started using it. You can basically just clone it from GitHub, use Maven package to build it, and then execute the jar. And if you want to try out SQLancer as quickly as possible, you can try to immediately test an embedded database system such as SQLite, H2, or DuckDB, because there you actually don't even need to set up the database system itself. SQLancer is distributed under a permissive license, specifically the MIT license. To also give you a feeling about how large the project is, it has about 30,000 lines of code, so it's not too small, but also not too big. It has 9 contributors, including myself as the primary contributor. One of the other primary contributors is Natsli, so she was an intern working at Citus Data, and where she added support for Citus. And she also wrote an excellent blog post explaining her experiences about using SQLancer and also using the test approaches. Then Patrick Steubele, he's a student at ETH, where he worked also on adding support for document-oriented database management systems such as MongoDB, and he also added support for AramcoDB and Cosmos. Well, and last but not least, Ilya, of course, also has been working on SQLancer, contributing, for example, ClickHouse support for it. Currently, SQLancer supports more than 10 database management systems, many of which you probably know, for example, SQLite, MySQL, Postgres, ClickHouse, and many others. So let me come back to what SQLancer is, and let's break down each of these individual components of the sentence. First of all, SQLancer is an effective testing tool. More specifically, I used SQLancer to find and report over 450 unique, previously unknown bugs in production quality database management systems, such as SQLite, MySQL, Postgres, and others. And if you're interested about the exact number of bugs and how they look like, you can actually also look at our repository, where we have a JSON file in which we documented all of the bugs that we found. SQLancer is widely used. Actually, quite a number of companies are already relying on it. And I want to give you a couple of examples for this. Yandex uses SQLancer to test every single commit of ClickHouse. Then DuckDB runs SQLancer on every pull request. MongoDB Solutions, they recently published a blog post stating that they have adopted SQLancer and used it to find and fix over 100 bugs in their system. Then PingCap, the company developing TiDB, they actually implemented a tool called Go SQLancer, in which they implemented the testing techniques that we came up with. Well, and as a fine example, I already mentioned Citus Data, so they have also been using SQLancer to test the releases of Citus. SQLancer is a tool for finding bugs in database management systems. And perhaps not everyone in the audience is very familiar with database management systems. So let's just briefly look on how they work on a conceptual level. Database management systems typically expect a query language as an input, such as the structured query language, or short SQL or SQL, that basically allows a user or application to interact with the database management system. For example, we can use this language to create a new database. We then can also create a new table. So here we create a table T0 with a C0 integer column. And just to very briefly recall the relational model on which most database management systems are based, in this model we basically have a table or relation as a central component, and multiple such tables can be joined together. A table consists of one or multiple columns that also typically have data types assigned to them, and data is stored as rows inside such a table. So if it is issue this create table statement here, what the database management system will do is to create an entry in its so-called database schema, remembering basically that we have created this table with this C0 integer column. Next, we can insert data in our database. So here we insert 3 rows with values 0, 1, and 2. And then perhaps most importantly, we can fetch our data again. So here we fetch all the records from this table T0 where this predicate P evaluates to true. Now P can be anything. It can be a comparison, for example, between C0 and some integer value or another kind of expression. What the database management system does is, at least on a conceptual level, to take this predicate, evaluate it on every row of the table, to then return the rows where the predicate evaluates to true as a result set to the user or the application. So this is how database management systems work on a conceptual level. SQLancer finds logic bugs in them. So what are logic bugs? Logic bugs are bugs that cause the database management system to return an incorrect result set. So you might also call them, for example, correctness bugs or semantic bugs. These bugs are difficult to find both for users and developers because silently an incorrect result is computed and, for example, the application does not simply exit with an error. To further illustrate this point, I want to explain this based on a concrete example. You can see here a test case for MySQL where I have 2 tables, T0 and T1, each of which holds a single floating point value, 0 and -0. And then we instruct MySQL to fetch the cross product of all values from T0 and T1, where the column evaluates to the same value. Now, what's the expected output here? I would actually argue that this is disputable, at least without having further domain knowledge. I think both options are plausible, that the predicate might evaluate to true or to false, because we can look, for example, at the binary representation of the 2 floating point numbers to realize that the sign bit differs. So it's 0 in one case and 1 in the other case. And based on this, it might be plausible that the comparison here evaluates to false. And in this case, MySQL would return an empty result set. But it might also be plausible that the predicate evaluates to true, because this is the semantics that most programming languages, such as, for example, Java and C, provide. And based on this, MySQL would expect it to fetch a single row. Now, at this point in this time, you have to believe me, actually, MySQL is expected to fetch the row. But when we tested the latest version of it, it still failed to fetch the row. We are able to automatically identify this as a bug, which was then subsequently fixed by the developers for the next release of MySQL. And the key message here is that we could automatically find the bug without even having an accurate understanding ourselves whether the predicate should evaluate to true or to false. And this brings me to the next point, namely that SQLancer is an automatic testing tool. So what does that mean? Basically, SQLancer operates in 3 phases. It first generates a database, for example, creating tables, inserting data into the tables. Then it generates a query. So here, a query that fetches the cross product from these 2 tables. It's basically the one that we have seen before. And as a final step, it validates the query's result. And SQLancer doesn't require any user interaction for any of these steps. This basically relates to the 2 challenges that automatic testing tools face. First, an effective test case has to be constructed, and there we manually implemented heuristic database and query generators. These generators work very similar to existing ones. So for example, there is SQLsmith, which is a very effective and popular tool for finding crash bugs and similar bugs in database management systems. And SQLancer's database and query generation works quite similar to such existing tools. What is new about SQLancer is that it tackles the so-called test oracle problem. And test oracles are the secret sauce, so to speak, of SQLancer. So what's a test oracle? A test oracle is basically the mechanism that decides whether a test case has passed or failed. And typically, we are the test oracle, right? We are writing test cases and we specify what the output of the test case should be. But in this line of work and for SQLancer, we're interested in automatic test oracles that can basically judge whether the result set is correct or not without any user interaction.
And can you show us some test oracles to demonstrate the idea?
Yeah, sure. So let me first talk about existing test oracles that already existed before SQLancer. One of them is differential testing, and probably some of you in the audience already thought about using this. The idea is in general that we have a test case generator that generates a test case that is sent to multiple systems that implement the same semantics. Each of these systems then returns a result, and we only need to compare whether the results are the same. If they are, then everything seems to work correctly. If they differ, then we have found a bug in at least one of the systems, assuming that they implement the same language. And this idea has been proposed also in the context of database management systems more than 20 years ago, where Microsoft Research proposed a system that is called REX. The idea of REX is that we have one random query generator that generates a query that is sent to multiple database management systems, each of which returns a result set, and then we compare the result sets. If they are the same, then all the database management systems seems to work correctly. If they differ, or if one of the result sets differ, then we have found a bug in at least one of the systems. So this approach is actually quite effective in practice. It also found many bugs in database management systems, but it has an inherent limitation, namely that it only applies to the common SQL core. And as we found, and as also other people found, is that the common SQL core is rather small because database management systems typically do not strictly adhere to the standard. They differ from it, they provide extensions, and also the standard doesn't describe all important features. This has also been stressed by companies. For example, Cockroach Labs, they published a blog post where they said that they're unable to use Postgres as an oracle using differential testing because Postgres, although it's the closest database management system in terms of SQL dialect, the two SQL dialects still differ, so it's tricky to generate test cases that execute and produce the same results on both systems.
So you showed test oracles that existed before SQLancer, and which oracles were proposed by you?
Yeah, so basically we proposed three different test oracles, namely Ternary logic partitioning, non-optimizing reference engine construction, and pivotal query synthesis. So what's behind these fancy names? Let's first look into ternary logic partitioning, which is the latest approach that we came up with. Ternary logic partitioning is based on a more general idea that we came up with, and we called this idea query partitioning. And in principle, it's quite simple. Basically, we have a query generator that generates a query that we call the original query, and you can also see here that this circle denotes the query's result set. And the idea is then that we partition the result set. Basically, we want to derive partitioning queries, each of which computes a partition of the result, so some part of the result. And then the idea is that we combine these individual partitions using a so-called composition operator to obtain a new result set. And the assumption is that the original query's result set and the composed partitioning query's result sets are the same. And we can easily check this. So if they are the same, then the database management system seems to work correctly. If they differ, then we have found a bug in the system. And in contrast to differential testing, we now only need a single database management system in order to find bugs. And we also can check the complete semantics of the operators, functions, and so on.
So it was not very simple to understand what's the result set and how we partition it. Probably we have a simple example.
Yeah, that's actually a good point. So let's actually get a step back and explain the technique or the ideas behind the technique in a very general context. So let's assume that Ilya and I are meeting in the coffee kitchen in order to get some coffee. Let's also assume that there is a bowl with fruits containing both tangerines and also clementines. Now, I'm actually pretty bad at telling these different kinds of citrus fruits apart because they all look orange to me, they all are round, they all taste sweet, so I basically can never remember which one is which. So let's assume the following situation. Basically, that I want to start some small talk with Ilya. So Ilya, are you ready with our dialogue?
Yeah, sure.
Yeah. So Ilya, I can never tell these different kinds of citrus fruits apart. They all look the same to me.
I think I can determine which fruit is tangerine and which one is clementine.
What? I don't really believe you. That's impossible. So show me. But actually, how can I test your understanding of this without even knowing the difference myself? Well, I have an idea. So Ilya, please bring me all clementines.
Oh, here they are. There are 2 clementines in the bowl.
Okay. Well, let me put them back into the bowl. I will also shuffle them so you don't remember which one was which. And now please bring me all fruits that are not clementines.
It is not hard at all. Here there are 4 fruits.
Well, I recognize the apple at least. And basically you brought me now 2 fruits in the first round, right? You brought me 4 fruits in the second round. So overall you brought me 6 fruits. And I can see that already some in the audience know where this is going, because there are basically only 5 fruits in the bowl. This means that you likely classified a fruit as being both a tangerine and a clementine. So I could point out your inaccurate understanding.
You're right. It's actually hard to differentiate them. And you proved I made an error even without knowing the correct answer. It was great.
Yeah, great. So what did we learn from this? I mean, one takeaway is that every object in the universe is either a tangerine or not a tangerine. And we use this insight basically to partition the set of objects and check the understanding of Ilya.
And how can we apply this idea to find bugs in database management systems? There are no tangerines there.
Yeah, that's a good question. Now we don't have a check for tangerines, but we have a general kind of predicate P. So this might again be a comparison between columns also. And then we have a general kind of row R rather than an object. Then exactly one of the following must hold. P evaluates to true, not P evaluates to true, meaning that the predicate evaluates to false. And now since we're in the world of SQL, where a Boolean predicate can also evaluate to null, not only to true or false, we also have the case that P is null, the predicate is null. And based on this insight, we can now take any kind of data in our database, any kind of intermediate result, and partition it into 3 parts. Namely those where the predicate evaluates to true, where it evaluates to false, and where it evaluates to null. Well, and how did we actually find now the bug in the previous example? We first generated the original query, and this basically corresponds to counting the number of fruits in the bowl. As you can see here, this query simply fetches the cross product of all values from T0 and T1. And MySQL expectedly computed the correct result here, so it returned a single row. Based on this, we then derived the partitioning queries. Based on this randomly generated predicate P, which here compares the 2 columns. And you can see that we once have a query with the non-negated version, with the negated version, and then also the is null version. And here, MySQL surprisingly returned an empty result set. It's surprising because we expected that the original query's result and the partitioning query's result sets are the same, which was not the case and allowed us to find this bug, and as I stated initially, without even being able to tell which of the predicate should have evaluated to true here. And the more general insight here is that the database management system is more likely to process the partitioning queries incorrectly due to the higher complexity.
Yeah, you showed one example. It was very simple. And what kind of features we can apply query partitioning to?
Yeah, the technique is quite versatile in the sense that it can be applied to quite a number of features. Let us briefly visit again how we can test work clauses, about which we also now have demonstrated in the example. Namely, we had this original query where we had the select statement with a from clause and potentially also some joins. And based on this, we derived these partitioning queries, namely 3 of them, where we added this additional where clause with the 3 different variants of the same predicate. And then we combined the individual result sets of these queries using the union all operator. And the union all operator basically merges the result sets, but it keeps duplicate rows. It can also be applied, for example, to test the correct execution of distinct queries. Now in the original query, we have this additional distinct clause. And in the partitioning queries, we omitted. This now means that in the composition operator, we need to filter out the duplicate rows. And we achieve this by using this union clause, which, unlike the union all clause, removes duplicate rows. Now, as a final example, we can also test aggregate functions, which are functions that compute the result over multiple rows. So let us first briefly look at a category of so-called self-decomposable aggregate function. I don't want to provide a definition of what this means, but let us directly look at an example. So if we test the max aggregate function, then the original query and the partitioning query just look like before, but now actually the composition operator looks different. Because the partition now is an intermediate result, namely the maximum value computed so far, rather than a subset of the result set, which was the case for the distinct oracle and for the were oracle. This means that we now need to use another application of the max aggregate function to compute the overall maximum value. Now let's look at a concrete example to better understand this. You can see here basically that we have the original query that computes the maximum value of this row ID column, and here CockroachDB returned a single row with the value null. And then we derive these more complex partitioning queries. And you can see that in the inside this parenthesis, we have, first of all, a max aggregate function to compute the partition values, namely the maximum values computed so far. And then we again have an application of the max aggregate function to implement the composition operator and to compute the overall result. And since here the two result sets differ, we are again able to find and report a bug. We can also test more complicated aggregate functions, namely, for example, those known as decomposable ones. For example, if we want to test the average aggregate function, then it quickly becomes clear that a single value to represent a partition is insufficient. Because if we, for example, would simply take the average as the result of a partition, then we wouldn't know over how many rows we computed it. So what we need to do is we need to keep track both of the sum and the count in order to compute the overall result. So Ilya, can you tell us a bit about what kind of bugs you found in ClickHouse?
Yeah, actually, we had a familiar bug like you showed in CockroachDB, and I'll show you another one. Here you can see the two queries and the results. So when you get a test failure with this approach, you get two queries that have different results. And we know they should be the same considering how we just made this query. So here we apply the ternary logic partitioning having approach in this case. SQLancer showed us the table schema, the data inserted, and the queries as well. So I tried to reproduce the example and to make it a minimal one. If we dig into this query, we can see that that having clause is used with a simple column that is not present in group by and not an aggregation result. Thus, we can see that this query is incorrect, but it returns some result, but it should not. So we found it was due to incorrect optimization and have a workaround that allows us to disable this behavior. So this query can return an error as it should. So, but SQLancer helped us to find this bug. Manuel, do you think the technique is quite general? I guess we can try to apply it to other domains?
Yeah, that's a good question. I would actually propose that we first, again, take a step back and look at the larger picture. Basically, what we did is we had in this query partitioning approach, we first of all generated this original query, we sent it to the database management system, and we obtained a result set. And based on the result set and the query, we derived a new query for which we could then provide the test oracle. Basically, we knew that the result of this query should be the same as the original query. In more general terms, we had this test case that we executed to obtain a result. And based on this test case, we derived another test case for which we could then provide a test oracle. And this technique is a general technique that is known as metamorphic testing. And actually, in our lab at ETH Zurich that is led by Professor Chanao Su, there has been other testing approaches that were proposed for quite a number of different domains. For example, also for testing compilers. you can see basically a technique that is known as equivalence modulo inputs that found about 1,000 or more bugs in compilers such as GCC and LVM. And there the idea was to execute a program, basically see what parts of the program are executed, and then manipulate the parts of the program that are not executed. Because this basically means that the derived program produces the same output for the same input. And this is the more general idea of equivalence modulo inputs, and an example for another metamorphic testing approach.
Yeah, I guess we can try to adapt this approach, for example, to API testing. So if we have some filtering or grouping in it, it can be used there. Or imagine if you write yet another regex library, I guess we can test it like this. So I guess we can find a lot of systems where we can test this approach, so query partitioning. So I guess for our audience, you can try to propose some ideas how we can test this approach, and it can be also used as like to define which question or which answer on this task will get the prize. So I guess it's interesting how we can apply the approach that we used for database management systems to another ones, because we love testing everywhere. So Manuel, and what about the another testing oracles? You showed us only one testing oracle, but you told about 3 of them.
Yeah, so another metamorphic testing oracle that we derived or devised is called non-optimizing reference engine construction, or short NOREC. And the goal there was to specifically find optimization bugs, so logic bugs that affect the query optimizer. Let us again look at the concrete example. You can see here a test case for SQLite, where we first create a table, then we insert a single row into the table, and then we want to fetch all rows from this table where this regular expression, this glob operator here, evaluates to true. And the expected result is that SQLite should fetch this row. However, due to a bug in the query optimizer of SQLite, it failed to fetch the row. More specifically, at the time that we tested the latest version of SQLite, the like optimization for regular expressions malfunctioned for the very specific case of non-text columns and this pattern prefix of dash. So how could we have found this bug using another technique? Again, the first thing that usually comes to my mind is, can we use differential testing? The idea would basically be that we have one query that we send to SQLite having all optimizations turned on. So if you're using GCCs and if you're using compilers such as GCC or LVM, you're probably familiar with optimization flags such as O3, which enables most optimizations, and O0, which disables most of them. And if we would have this for database management systems, we could enable the optimizations in SQLite to first of all return or obtain the incorrect result set. And then we could disable the optimizations to obtain the correct result set. And then by comparing the results, we would be able to specifically find such optimization bugs. However, if we look through the list of options that are provided, for example, by SQLite, the closest option that we can find is the one that controls the case sensitivity of such regular expression operators. And obviously, that doesn't really help us for finding such optimization bugs. In more general terms, database management systems typically provide only very limited control over optimizations, and only some of them allow disabling all optimizations altogether. So the idea in this work was, why rely on the database management system? Why not rewrite the query so that the database management system can no longer optimize it? Basically, the idea would be that we have again one query generator that generates a so-called optimized query, namely one that likely triggers optimizations in the query optimizer and would return the incorrect result. And then we would have this translation step that derives the unoptimized query, one that doesn't trigger optimizations in the query optimizer, or at least to a lesser degree, to then, for example, not trigger the bug and obtain the correct result. And this is where the name comes from, because we're now basically creating a non-optimizing reference engine, namely one that doesn't perform any optimizations. Now let us concretely consider the following format for the optimized query. Namely, we fetch a number of records from some tables, one or multiple tables, where this predicate evaluates to true. In our case, the predicate is this regular expression operator. Based on this format, it's actually not obvious how we could derive an unoptimized query. In order to realize the approach, we had two insights. The first insight is that the predicate P must always evaluate to the same value, irrespective of where exactly in the query it is used. So basically, we can take this predicate from the optimized query and move it directly after the select statement. Now, what's the effect of the second, of the unoptimized query? Well, first of all, the result set will be as large as records contained in the tables. And the result set will consist of true, false, and null values. For example, it will contain true for every predicate, for every row where the predicate evaluated to true. So in this case, this means that basically the result set will contain a single row with the value true. And these two parts have to correspond, because basically the number of rows returned for the optimized query has to be the same as the number of times that true is contained in the second query. Now, the second insight was that database management systems focus their optimizations on reducing the amount of data that is processed. Basically, for the query where we have this verb predicate, SQLite, in this example, decided to use an index, an auxiliary data structure that makes query processing faster. But for the second, for the unoptimized query, SQLite decided to simply scan through the table, which is unsurprising because this predicate needs to be evaluated on every row of the table anyway, so there aren't really any optimizations that would increase the performance here. Now let's take both of these insights together. Namely, we first send the optimized query to SQLite, in which case the incorrect result is returned. And then we send the unoptimized query where we have moved this predicate to the front. And here SQLite returned a single row with the value true. And based on this, we can actually infer that the optimized query should have contained exactly one row, because exactly one true value is contained for the optimized query, for the unoptimized query. And since this was not the case, we could find and report this bug. Actually, implementing the technique is quite straightforward because we can use aggregate functions for implementation. Namely, for the optimized query, we can use the count aggregate function. And for the unoptimized query, we can use sum to sum up how often the predicate evaluated to true, in which case it is implicitly cast to 1. And basically have these two integers returned that we can directly compare to each other.
So you showed us two metamorphic testing oracles, and you told that there are non-metamorphic ones. Can you give us an example?
Yeah, so pivotal query synthesis is one example of a test oracle that follows a conceptually different way. As with the two other test oracles, let's first look at a motivating example. You can see here a test case for SQLite, where we have this query where we have a predicate that uses the is-not operator. The is-not operator is a so-called null-safe comparison operator in the sense that even if one of the operands evaluates to null, the result of the operator will still evaluate to either true or false. So what's the expected output of this query? Well, 0 is not 1 should evaluate to true, so this should be part of the result set. 1 is not 1 evaluates to false, so it won't be part of the result set. 2 is again of the result set, and since we're using the null-safe comparison operator, also null is not 1 will evaluate to true, and thus be part of the result set. However, when we tested the latest version of SQLite, null was not contained in the result set, and we could find this bug and report it to the developers using the technique that I'm presenting next. So the idea of pivotal query synthesis, or short PQS, is that we want to use a divide and conquer approach for testing database management systems. Specifically, we want to validate the result set based on one randomly selected row at a time. And we refer to this randomly selected row as the pivot row. As a next step, we generate a query that is guaranteed to at least fetch the pivot row, potentially among other rows in the result set. And you can see that here we have already created this statement that is expected to fetch the pivot row. As a final step, if the pivot row is missing from the result set, which we check, then a bug has been detected. If it is contained, then we cannot, of course, detect a bug in the system. So let's look at the specific steps into more detail. First, we randomly generate a database, which is similar for the other test oracles as well. But then we basically tackle the test case generation problem and the test oracle problem at the same time by first selecting a pivot row, which is one random row that we select from multiple tables and views. Then we generate this query that is guaranteed to fetch the pivot row. And here our insight was that we only need to generate predicates that evaluate the true for the pivot row, because then we can use them in join and work clauses directly, knowing that the result set will contain the pivot row. As a first step, we generate a random predicate. Here we already have our predicate that triggered a bug, namely the is not operator here. And now, different to the metamorphic testing oracles, we implemented an expression evaluator for each node. We use this expression evaluator to evaluate the tree based on the pivot row, meaning that if we have a column reference, it simply returns the value from the pivot row. So this reference to C0 returns a null value. The other kind of leaf nodes are constant nodes, and they return their assigned literal values. So here we'll return 1. And then compound nodes compute the result based on their children. So this is not operator will check whether the left and right result are the same. Since they are not here, it returns true. And now we know that the predicate evaluates to true, and we can directly use it in the work clause, or we could have also used it in a join clause, knowing that the pivot row will be part of the result set. But what if the expression does not evaluate to true? In this case, we have a simple fix-up step. If it evaluates to false, we append this additional not operator. If it evaluates to null, we append this additional is null operator. And this ensures that the predicate will then also evaluate to true. As an alternative, we could also have validated that the pivot row is expected not fetched, namely when the predicate evaluates to false or null. And as a final step, we use the database management system to check whether the row is contained. So here, this intersect operator, if basically the result of this query for SQLite here is non-empty, we know that the pivot row is contained in the result set.
So you described 3 quite different techniques. Imagine I want to start testing correctness using them. What should I try first?
Yeah, that's a good question. So in general, all the 3 techniques, they are complementary in the sense that each of the techniques found unique bugs that only the respective approach can find. But there are, of course, some common advantages and disadvantages. Namely, if we look, for example, at Ternary logic partitioning, we realize that I've demonstrated how we can test, for example, aggregate functions using it, and this is not the case for the other techniques. So pivot accrual synthesis and non-optimizing reference engine construction, they are primarily useful for testing the correct implementation of work clauses. Both NOREC and Ternary logic partitioning are so-called metamorphic testing approaches, as we already know by now, and this has some implications. First of all, the domain knowledge required for implementing such approaches is rather small, right? Because we didn't even, we could basically know that the database management system has a bug without knowing whether the predicate should evaluate to true or false. And also the implementation effort is low for these approaches. The advantage of pivot accrual synthesis is that it establishes a ground truth by having these expression evaluators to which we can compare our results to. But the disadvantage is that the domain knowledge required to realize the technique is higher, and also the implementation effort is higher because we have to implement these expression evaluators. So if I would go ahead and test a new database management system, what I typically would do is I would first use NOREC to quickly find a number of implementation bugs, which are typically considered to be the most important. Then I would use Ternary logic partitioning to also comprehensively test also aggregate functions and other features. And finally, I would use pivot accrual synthesis to also comprehensively test the database management system's core functionality. But maybe you can also share your experience. So what implementation strategy did you use for ClickHouse, Ilya?
Oh, thank you, Manuel. Actually, when you start looking at a new tool, you just try to read the README papers if there are some and try to think what is going on inside. So I looked at SQLancer, and as a developer point of view, I saw that it is quite natural and intuitive. So I understand what's going on, probably in some of the historicals, but it was like natural for me. I have seen that it's like the fuzzing meets the correctness check. So we have combined tools that can help us both run something like fuzzing and show that our results are correct. And it was pluggable. So it was pluggable. You just need to write code in Java, and you can get your the database management system integrated in SQLancer. So when I looked at it, I tried to start with TLP Oracle. So for me, query partitioning was the most interesting one. So when I looked at SQLancer, some part of ClickHouse integration were already on. So Manuel already started integrating it with ClickHouse, but it was like at the beginning, and it didn't work at that moment. So I'll just run through the process how to integrate your database management system to SQLancer, just to show you the idea. So at first, we need to add your driver. So in case of SQLancer, you just add the dependency of the ClickHouse JDBC driver, and that's it. It already works well. Then you need to teach SQLancer to make connection, to create database, and to make a generic query. It looks like the simple how to use your JDBC driver. Then a bit more difficult part, because it depends on your database management system and features that you have inside it. So you can just, so you need to create a table and a schema of this table. So you need to know which types of columns you have, which are some extensions that you can use. So you can just take a subset of the features you want to test and to create some schema generator and table and teach how to create a table. It's also not very difficult. Then you should need to generate expression. So it's like the code that actually trying to use the columns that are inside the table and some other expressions. And I guess this part can be improved infinitely. So you always can improve the generator, add more cases, add new functions, new features. So I just took the subset of features that was easy to implement and added it to SQLancer ClickHouse support. And the next step was implementing the test oracle, but actually it's like the copy paste because of we did not do the refactoring in time. So we just need to a bit change the SQLancer. Just you don't need to implement it itself, but I showed it also because it's like 20 rows of code, and it's all the logic that Manuel showed us before. So it's like the TLP where Oracle, and the main idea is like in 5 rows of code. So you run this integration and you run SQLancer. What you get? For example, you have seen the error in the in some run. You see the query which failed and try to analyze whether this query was correct or not. Actually, if it was incorrect, it's okay, because your database management system should not fail, crash, etc. with the bad query. So your generator can generate bad queries, and it's totally normal. So if syntax was incorrect, you can just add this error in the list of the issue of errors that are muted, and it is done by SQLancer just not to show you this query failures. Then the next question is whether you obtained the result or not. If you have not obtained the result, something went wrong. Probably your database management system crashed or something hung inside. So it is not normal that you have not get the result. You should look at the logs of your system and try to analyze whether it's working or it crashed, and you probably found a bug. It is very nice, but actually it looks like the any other fuzzer that we can use can trigger the same bug eventually. So it is not the SQLancer main value. But if you got the result and you had the two different results in the query and the partitioned query, it means that SQLancer found the correctness bug, and this is what we were trying to find in our database management system. So I also want to point out that if you already have some fuzzer, some query generator that you already use in your testing environment, you can try to incorporate the idea and implement Oracle yourself. Just look at this slide. You can see that there are like small queries that you can just add as a hard code and test your database management system with all the features that you already know how to generate or how to mutate. So you can just get the idea and integrate it in your tools, like it was done in SQLancer, for example. So Manuel, yeah.
Yeah, you might wonder about how you could contribute to SQLancer, and there are many different ways, and I want to just outline some of them. So contributions are highly welcome, and one example of a contribution would be to add support for a new database management system, which is always very insightful and allows you to find perhaps many bugs. Then also automatic reduction of test cases would be a possibility to experiment with new test oracles, modularize the code. So Ilya already mentioned that some refactoring is also always necessary. And you can also contribute in other ways, for example, by writing blog posts, tutorials, and so on. And with that, I want to summarize our talk. So first of all, we presented ClickHouse, which is an analytical database management system. Then we explained SQLancer, a tool for finding logic bugs in database management systems. We outlined the 3 techniques that SQLancer implements to tackle the test oracle problem. One of them being the query partitioning approach, where we also use the analogy with tenderines and clementines to illustrate the key ideas behind it. And even if you are not working on database management systems, we believe that the insights of the talk might still be interesting for you. For example, you learned about differential testing, also heard about metamorphic testing, and there are metamorphic testing techniques that apply for many different domains. And finally, we also showed you how you can get started using SQLancer to test your own database management system. So with that, thanks for listening, and Ilya and I would be happy to take your questions.
Thank you a lot. That was great. That was really amazing. Lots of new techniques. Well,
yeah. Metamorphic testing, never heard about it before. The new buzzword maybe in a few years. Everyone will be making metamorphic testing.
I guess universities and companies should talk more with each other, right? We can learn a lot from each other. So,
yeah, that's great. Well, my immediate question is, well, you mentioned several times during the talk that you create query that tricks database so it cannot optimize something, or it has to do it several ways or slightly different ways. But what if database optimizes the query right to the original form? For instance, when you partition the query into several union all operators, the database itself can infer, well, this is the same query. I would just fold all of this into a single select statement without filtering, without work, and without union all. How do you handle it?
Yeah, that's a good question. So I think that would be very much possible in principle, but in practice, I think that database management systems, they have many constraints, right? They can only take so much time in order to process a given query because the user is waiting for it. And I think in practice, database management systems lack many optimizations that, for example, optimizing compilers apply because simply they have less time to do their optimizations. And even if a database management system undoes the optimization, then basically we have to look for a new testing approach, for a new test oracle. So I think that's the nice thing about thinking about this different kind of test oracles, that you always need to take into account the context in which you are developing them. So what kind of optimizations, for example, a system does.
Yeah, that's awesome. It's kind of constant battle for weapon and shield. So you need to fight against it. Yeah, and I wonder, well, you mentioned that SQLancer generated invalid SQL with referencing a wrong column in having clause. Was that intentional or was it accidental? So do you consider it as a bug on the generator side, or is it a true bug people should identify with SQLancer?
So I guess that if you have the bug on generator, it's totally okay, and you can just probably make it more. So you should increase the probability that you have the query that actually returns a result and not just shows you an error. So if you have 100 queries that is not correct, and you always give some error, it's not the way you want to test your database management system. So you try to make different, so randomly you generate bad queries. So try to make it less probable to generate a query like this, so you can improve it and make. So actually, when you run SQLancer, you can see that how many queries that you run did not return an error. So you can see that it's like 30% or 60%, and it's normal. If you have 90% of bad queries, it is, I guess, not the correct generator. You need to just improve it a bit.
Okay, and I have a question concerning applying SQLancer for things other than databases. You mentioned event streaming as a possible application for it. As far as I know, many event streaming, event processing systems like Kafka, they have things like KSQL, and there is also things like Esper, who make their own SQL-like languages for event processing. Do you know if anyone tried to use SQLancer for this stuff? Is it even possible to use SQLancer to test event processing systems who try to use SQL-like languages?
You want to take the question, or should I, Ilya?
So I guess we can both. My point of view is that it is totally normal to use SQLancer logic in, for example, KSQL, because if you just make a streaming SQL query and get the same input to two queries, they should get the same result. So you can just install these queries like in streaming mode and compare the results. So it's totally the way we check SQLancer now, with SQLancer now. So, and your point of view?
Yeah, so I agree with what you said, and also we've already started exploring other kind of database management systems. So we thought, for example, about different kind of NoSQL systems and about specifically how we can test document-oriented database management systems like MongoDB and so on. And it seems, for example, although some of the techniques that we presented are applicable in principle, it actually didn't uncover many new bugs. So it might be that, again, if we now venture into other related domain, that we need perhaps some slightly different kinds of insights. And then we could, for example, think about new ways of how this partitioning approach applies, because I believe that the ideas behind these approaches are quite general, as we also demonstrated with this Mandarin analogy.
Yeah, that's interesting. I wonder, where do you get the data from how do you know which tables are there in the database and who created them during the test?
Yeah, so typically, as Ilya shortly presented, a developer has to write some glue code to make SQLancer work. And part of this glue code is to read out the database schema and use it for generating these statements and so on. So typically, you need to implement a routine that simply reads all the tables from the schema, all the columns, and then later on, when you generate, for example, this insert statement, you again use the information that you read from the database management system.
Okay, does it mean that SQLancer cannot explore, like, I don't know, creating index during the test? So is it outside of SQLancer or can it be integrated? I mean, consider we have a query, and if we create an index, it might alter the behavior because optimizer can now use it. So we might want to test their outputs without index and with index created.
I see. Yeah, that's a great question. Actually, we found that this no-rec approach disables indexes. So this is basically one of the insights that if you issue the optimized query, it will typically use an index if it's profitable. But if you use the unoptimized query, then it disables the use of indexes. But that would also be an idea, right? You can use differential testing where you first create a database with indexes and then the same database without indexes. And by comparing the results, then you can implement differential testing.
Okay, thank you for your talk. Thank you for discussion. We're running out of time, unfortunately, and we can proceed with discussion in Zoom. And everyone who are watching us, please join us in Zoom session. I believe I will be able to join you folks in 5 minutes time. So thank you very much once again, and bye-bye.
Thank you. Bye-bye.
Thank you for listening. Bye.